Hello everyone, this video is for economic group presentation. We are group A4. I am 陈乐丁李根瑞。区域心理二陈应慈。
Today I'm going to introduce topic 1, Trumponomics, tariff impacts between the United States and Taiwan. Tariff policy and reciprocal tariff. Let's explain the concept of tariff. When foreign products are imported, our country places a tariff on those imported products to raise the price of imported products so that the quantities can be lower. In this case, the tariffs can protect domestic suppliers. What does the reciprocal tariff mean in the context of US-Taiwan trade?
Okay, let me give you an example of reciprocal tariff. Suppose I want to export pens to you, and you want to export erasers to me. Now you impose a 30% tariff on my pens. What do you think I would do?
You'd retaliate against me, right?
Exactly. Because you taxed my pen at 30%. When you export eraser to me, I also want to impose a tariff on you in return.
What? Then wouldn't it just hurt both sides, like mutual damage?
You are absolutely right. It really is hurting each other. A reciprocal tariff means whatever tax you impose on me, I impose the same tax on you, in the name of fairness.
So, can this be used as a negotiation tool in economic and trade relations?
Since you mentioned it, let's take a look at how reciprocal tariffs actually play out between Taiwan and the US.
And I'll give example of how the US and Taiwan have implemented or faced reciprocal tariff under Trumponomics. The United States used the idea of reciprocal trade to justify raising tariffs, such as the 25% tariff on steel and 10% of aluminum under Section 232. Arguing that U.S. tariff levels should match those of its trading partners. Taiwan was affected by this measure, but chose not to retaliate with reciprocal tariffs, because doing so could harm its key export sectors in strategic relations with the United States.
Instead of imposing counter tariffs, Taiwan relied on negotiation, supply chain cooperation, and concessions such as easing restrictions on U.S. pork imports. Thus, the reciprocal tariff dynamic between the U.S. and Taiwan was characterized not by symmetric tariff retaliations, but by U.S. tariff actions and Taiwan's strategic restraint, which aimed to minimize economic damage and persevere long-term cooperation.
Alternative policy instrument. Let's compare tariff with quotas as tools for trade protection. Both tariff and quota can protect domestic producers, and both ways result in identical outcome. And let's see the graph first. This is a graph. And next, let's see the form. The difference in the area G, which represents the tariff revenue in tariff policy and additional revenue earned by importers who have import license in quota policy. Besides, two ways yield different new supplies curves.
Under what circumstances might a country prefer a quota instead of a tariff? Based on this form, we can see the different situation whether a country will choose to quota or choose to tariff. The first one is government wants revenue. If the government wants revenue, it will choose to tariff. If want a flexible adjustment of import quantity, the government will choose tariff. If the government wants to fix import quantity strictly, it will choose quota. If the government wants to want the strongest protection for domestic industries, it will choose quota. Quota is not comply with WTO rules. So if the government wants to comply with WTO rules, it will choose tariff.
How do these two policies differ in their impact on market efficiency and government revenue? Tariffs and quotas both reduce import and create state laws, but they work very differently. With a tariff, the government collects money from each unit that comes in, so the government actually earns revenue. But with the quota, the government doesn't get any revenue. Instead, whoever holds the import license, often foreign exporters, gets the extra profit, which we call quota rate. In terms of market efficiency, a tariff changes the price, so the market can still adjust the import quality naturally. Because of that, the distortion is smaller. A quota, on the other hand, fixes the import quantity. It's a very rigid restriction, so the price usually goes up even more compared to a tariff. When you add a quota rate on top of that, the total that was lost becomes bigger. So basically, tariffs distorted the market less and give the government revenue, while quotas create bigger distortion and no revenue.
Okay, the third question. Graphical analysis. U.S. reciprocal tariff and U.S. import market. Use a domestic import market diagram from the U.S. perspective. This is the import market diagram from the U.S. perspective. Show how the tariff changes the domestic price, import quantity. Okay, let's recall the diagram I showed before. When the U.S. imposes a reciprocal tariff on Taiwanese goods, the price of Taiwan's products in the U.S. market rises. Because these goods become more expensive, U.S. consumers reduce their quantity demanded, which leads to a decline in U.S. imports. At the same time, the price received by Taiwanese exporters falls due to weaker U.S. demand. As a result, Taiwanese exporters sell less, and the United States imports less from Taiwan, and the U.S. government protects domestic supplies.
And that graphically analyzes the U.S. reciprocal tariff and Taiwan export. This is the supply-demand diagram for Taiwan's export markets to the U.S. And I'll show and explain how a U.S. reciprocal tariff shift curves, alters equilibrium price and quantity, and affects Taiwan's exporters. When the U.S. imposes a reciprocal tariff, the price of Taiwanese goods in the U.S. market increases because U.S. demand for Taiwanese export falls. The price that Taiwanese exporters effectively receive decreases. As a result, Taiwanese producers export less and earn less revenue. Welfare effects on Taiwan. Analyze how the U.S. tariff impacts Taiwan's consumers, producers, and government. The U.S. tariff makes Taiwanese goods more expensive in the U.S., so Taiwan's export quantity falls. This mainly harms Taiwanese producers who receive a lower price and earn less. Taiwan's consumers are only slightly affected since the tariff targets export, not the domestic market. The Taiwan government receives non-tariff revenue and faces indirect pressure because weaker export reduce overall economic performance and require policy or negotiation responses. How does the export decline influence Taiwan's overall economic welfare? Let's see a graph first. And let's look at the form. In this form, before tariff, the area of consumer surplus is A, but after tariff, the consumer surplus becomes A plus B. And the producer surplus after tariff is only have C plus G plus H. The total surplus is smaller than the before tariff. It's only A plus B plus C plus G and H. The total revenue is the same, but after tariff, they have deadweight loss. It's D plus E plus F.
Okay, the last question. Welfare effects on the United States. Analyze how the reciprocal tariff impacts U.S. consumers, producers, and the government. Evaluate net welfare effects considering tariff revenue versus efficiency loss. Okay, let's look at the diagram first. And here is the comparable form. Before the tariff, the consumer surplus is A plus B plus C plus D plus E plus F and plus G. After tariff, it remains A plus B plus C. And the producer's surplus before tariff is only H. After tariff is D plus H. The total surplus before tariff is A plus B plus C plus D plus E plus F plus G and plus H. But after tariff, it remains A plus B plus C plus D plus H. The tariff revenue. After the tariff, the US government will receive the area G as tariff revenue. But after tariff, it will cause deadweight loss, is which E plus F. Okay, that is topic 1. Hello, I'm Chanleding Ling Enrui. Today I'm going to introduce topic 2, TSMC as a dominant producer in the advanced chip market, pricing, cost, and competition. Okay, the first question, monopoly pricing and quantity determination. Using a monopoly diagram, explain how TSMC determines its profit maximizing price and quantity for advanced AI chips. Show the monopoly price, quantity, and profit area. Explain the welfare loss compared with perfect competition. So based on the diagram, we determine the quantity demanded by MR equals NC at QN, and the price at PN, which is on the demand curve. This price is the profit maximizing price for TSMC. And the green area is the profit area. It's the gap between PN and PATC times QN. In terms of the competitive market, the marginal cost curve is the supply curve of a competitive firm. Based on the same diagram, we determine the quantity demanded that MC equals MR equals PC. That is, supply curve intersects the demand curve at QC, and the price is MC equals MR equals PC. Comparing the perfect competitive firm with the monopolist, the red area is the deadweight loss. Discuss how factors such as AI chip demand surge shift the demand curve and affect the equilibrium price and output. Okay, based on this diagram, when the demand increases from D to D prime, the demand curve shifts to the right. And this leads to the price rising from PM to PM prime, and the quantity demanded rising from QM to QM prime. That shows the surge of AI chips demand and the consequence equilibrium price and output. Okay, the second question is TSMC's cost structure. What types of fixed costs and variable costs does TSMC face in producing advanced chips? Fixed costs such as building new fabs, EUV machines, R&D for advanced nodes, and long-term equipment depreciation. The variable costs are electricity and water, chemical materials, wafers, labor used in production. Explain how high fixed costs and economies of scale reinforce natural monopoly characteristics in semiconductor manufacturing. First is economies of scale. Because TSMC has extremely high fixed costs and falling average total cost, as production increases, the industry shows economy of scale. As TSMC increases its production volume, the average total cost, ATC, per chip falls because of the massive fixed costs are separated over a much larger number of units. And the huge initial investment and the resulting falling ATC over a large output range mean it is most cost efficient for only one firm, TSMC, to supply the entire market. This makes it nearly impossible for new competitors to enter and match TSMC's low unit cost, and that is the natural monopoly. And this diagram illustrates the economy of scale. You can see the constant MC curve, which is always under the ATC curve. And this situation makes the ATC curve a downward sloping curve, so that the monopolies can decrease its average total cost by increasing the quantities, and natural monopoly appears. Okay. The third question, profit visualization. Show within the monopoly graph how to measure TSMC's economic profit. Okay, based on this diagram, as we mentioned before, we determine the quantity at where M are equal to MC, and we find Qn. And then we find Pn on the same quantity on the demand curve. And based on the Qm, this quantity, we find PATC. So the gap between Pn minus PATC times Qn, the quantity, is a green rectangle. That is the TSMC's economic profit. Explain why TSMC can sustain positive long-run profit in advanced nodes, while competitors struggle to match its efficiency and yield. Because of the extreme high barriers to entry and efficiency. First is capital barrier. Competitors need tens billions of dollars just to build a comparable fab. And technological barrier. TSMC has a substantial lead in yield rate and process know-how. The third is efficiency. TSMC's superior efficiency and yield result in a low marginal cost curve compared to competitors, securing a large profit margin, that is, economies of scale. And this diagram illustrates those barriers I just mentioned. Because TSMC is a monopolist, so it can decide its own price at PM. And the gap between PM and PATC times QM is its long-run positive economic profit. That's why it can earn positive economic profit in the long run. However, taker, so they can't decide their own price. The market decides the price at P equal to MR, and where the lowest ATC. That is efficiency of scale. It's not economy of scale. So it will earn zero profit in the long run. Okay, the fourth question. Factory expansion. Long run versus short run. TSMC is building a new fabs in the US, in Japan, and Germany. Are these short run or long run decisions? To answer this question, we need to know the definition of short run and long run. Short run, time period where at least one input is fixed and cannot be changed. However, the long run is the time period where all inputs are variable. Firms can choose to change the scale of their operations. Take TSMC for example. In the short run, TSMC can increase production by running existing machines longer or hiring more workers. In the long run, TSMC can build an entirely new fab. So the question, factory expansion decision is a purely long-run decisions. This involves changing the company's capital stock, like building new factories, changing their production capacity, and invest in expensive equipment. In the long run, all factors of production are variable. Discuss the role of fixed investment in shaping these long-run production decisions. The first is fundamental change in capacity. Building a new fab is not just a small tweak. It is a fundamental shift in TSMC's total ability to produce chips. It is a decision that locks in massive capital and sets the production capacity for the next few decades. The second is strategic planning. TSMC makes this huge commitment based on its long-term forecast for demand, such as expecting massive AI and HPC growth for the next 10 to 20 years, not just short-term market fluctuations. The third is achieving future scale. These expansions are designed to ensure TSMC can continue to capture economies of scale globally, allowing to maintain the lowest unit cost as overall demand increases dramatically. Okay, the last question. From monopoly to oligopoly, enter of Intel or Samsung. If Intel foundry survives or Samsung foundry successfully develop comparable 2 or 3 NM technologies, how would the market structure change? If Samsung or Intel successfully develop comparable 2 NM or 3 NM technology, the market will shift from a monopoly, one dominant firm, to an oligopoly, a few large competing firms. First is the increased competition. TSMC will face direct competition for advanced customers. The second is price pressure. The new capacity and comparable technology will force TSMC to lower its price. The PM will fall, moving closer to its MC, marginal cost, and eroding its monopoly profit. The third is higher output. The total market output will increase, and the deadweight loss will shrink. The fourth is focus shift. Competition will intensify in non-price factors like yield rates, customized devices, and supply chain reliability.
I'm 心理二陈映慈. Today I'm going to introduce topic 3, air pollution, and negative externality. Why the market fails and how to fix it. We will follow each point step by step. Let's understand the case first. Our real-world example of air pollution is coal power plant. Coal plants emit sulfur dioxide, nitrogen oxide, and fine matters such as PM2.5. This emission creates several negative externalities. First, they cause respiratory illnesses, which increase health costs. Second, they reduce crop yield, creating agriculture losses. Third, they reduce visibility, which affects transportation safety. And fourth, they contribute to climate change, creating long-term global costs. In this case, the producers of the externality are coal power plants. The victims include nearby residents who experience health problems, the border city affected by smoke, and even future generations who face long-term climate consequences. Why a negative externality leads to market failure? The definition of a negative externality is a situation where a free market, operating on its own, fails to allocate resources efficiently, resulting in a loss of total social welfare. A negative externality leads to market failure because producers consider only their private cost, PC. They ignore the external costs, such as health damage or environmental harm. This means the true social cost, SC, which equals PC plus EC, is higher than the cost reflected in the market. Because the market price is too low, first produce too much. This overproduction results in a loss of social welfare, which we call market failure. This is the graph. In our graph, we compare private cost, PC, the cost that first actually paid, social cost, SC, the true cost to society, which equals PC plus the external cost, and private benefit, PB, the demand curve that reflects consumers' willingness to pay. On the graph, PC intersects PB at a market equilibrium. This gives a market quantity, Q market, and market price, P market. However, when we include the external cost, the SC curve lies above the PC curve. When SC intersects PB, we find the socially optimal quantity, Q social, and the social optimal price, P social. Because SC is higher than PC, Q market is greater than Q social. The market produces too much output and too much pollution. While the market produces too much pollution without government intervention. The market produces too much pollution because producers only consider their private cost. They do not account for health damage, environmental cleanup expenses, or long-term social costs. Since less internal costs fall on society instead of the producer, the market price ends up too low. This encourages excessive production, leading to excessive pollution. In the graph, the dead weight loss is the red triangle formed by two things. The vertical gap between the social cost and private cost curve, and the output difference between Q social and Q market. These red triangular areas represent the welfare society loss due to excessive pollution. Producers gain because they produce more at a lower private cost. Consumers gain from lower market price. But society lost through increased health costs, environmental damage, and overall welfare reduction. How less-stable laws represent inefficiency. Less-stable laws represent inefficiency because between Q social and Q market, the social cost of each additional unit exceeds the social benefit. In other words, every unit in this range harms society more than it benefits consumers. These units should not be produced in an efficient economy. Their existence is an essence of market failure. Correcting the market failure. The first is command and control. What kind of regulation of standard could the government impose, and its pros and cons? One government's approach is command and control regulations. This includes emission ceilings, which limit how much pollution a plant can emit per year. It also includes technology mandates, such as requiring scoopers or other pollution control devices. This has advantage. They provide certainty and achieve spatial emission reduction, and they are often simple to enforce, especially for dangerous pollutants. But there are drawbacks. They are inefficient because they impose the same rules on all firms, even though firms have different abundance costs. And they reduce incentives for innovation once the standard is met. The second is market-based. Correcting the market failure in a market-based solution. Pigouvian tax. A Pigouvian tax charges polluters for the external costs they impose on society. The goal is not to punish first, but to internalize the externality. Before the tax, producers ignore external costs. After the tax, the private cost shifts upward until it's equal to the social cost. The market price now reflects the true cost of production and first naturally reduce output to the socially optimal level. Internalized externality. The Pigouvian tax must equal to the external cost at the social optimal quantity. This shifts the private cost curve upward so that it exactly overlaps with the social cost curve. On the graph, we illustrate this by shifting the marginal private cost upward by the amount of tax. The new curve coincides with the social cost curve, and the new equilibrium occurs at Q social and P social. Now let's introduce the real-world policy example. The air pollution control fee in Taiwan. A real example is Taiwan's air pollution control fee. This is a direct Pigouvian tax. Polluter pays a fee based on how much pollution they emit. The fee converts external costs into private costs, encouraging firms to adopt cleaner technologies. Was it effective? What were the challenges? The policy was effective. Industrial emissions decreased, and Taiwan's air quality improved. However, the biggest challenge is setting a fee rate. If the fee is too low, it doesn't change behavior. If it's too high, the industry strongly opposes it politically. The extent is thinking. Suppose pollution affects neighboring countries. How does this create an international externality? Some pollutants travel across borders, like smoke, acid rain, or CO2. This creates an international externality. Country A benefits from polluting, but country B suffers the environmental and health costs. Because country B cannot tax polluters in country A, global pollution becomes too high, creating global inefficiency. Can international cooperation act as a Pigouvian mechanism? The answer is yes. International cooperation can function like a Pigouvian system. Carbon market, such as emissions trading systems, put a price on carbon. This price acts like an implicit Pigouvian tax forcing companies to internalize the global cost of emissions. And the second is climate agreement, like Paris Agreement, sets national target. To meet this target, countries adopt domestic policy such as carbon tax or regulations. These national policies become extra Pygmalion tools that correct the global externality. In summary, air pollution is a classic example of a negative externality. It causes market failure because private costs are lower than social costs. Graphically, this results in overproduction and labor loss. Governments can step in using common and control regulations of Pygmalion tests, and because pollution across border, international cooperation is essential. Thanks for listening.